In just a few minutes, we are going to start turning on components on the board. And we're also going to set up this rocket motor right here, just to show you how easy it is to have fun with the EZA board. But before we can do those things, we do need to talk about some basics. So let's just get those out of the way quickly. And I'll start by typing 2 forward slashes. Now this indicates that whatever follows is not code, but a comment, meaning a note to yourself. And I'm going to use 3 of these comments to talk about the 3 sections of an Arduino program. And the first section is simply a list of items. It's like before you go on vacation, you have a list of things. Everything you pack now will be available later. For example, we'll be saying, you know that pin 30? We'll be using that later on to control the backlight. Now it's important that this is a list of items, not actions. Because actions have to go in functions, and functions are up next. You say, hold on, what is a function? A function is a group of actions with a common purpose. For example, here we have the setup function, and the purpose of the setup function is to set the chip up for operation. And the setup function is the ideal place to do these configurations because the setup only runs once on startup. So, for example, we'll be saying to pin 10.2, I'm now configuring you as an output so that you're capable of sending out a signal to the rocket motor. See, that only needs to happen once. We'd put it right at the beginning and then we're done with it. Lastly, and most importantly, we have our loop function. Here's where all your main code goes. And it is called the loop because the microcontroller will go through the code here and then loop back to its beginning and go through the same code again. It's a bit like you and me. You have a routine, you wake up, you go to work, and every day more or less you follow the same routine. The microcontroller, however, will do this much quicker, so depending on how you write your code, this can easily happen thousands of times per second, going through the same code over and over again. So it repeats forever. At least as long as the chip has power. Okay, that is it for the basics. Now let's actually write some code, starting here with the setup function. And to declare it, I simply type void setup all lowercase. Now the loop function, equally simple. We say void loop, also all lowercase. Now every function has behind it a set of parentheses and a set of curly brackets, a set of parentheses and a set of curly brackets. And then your code will go inside those curly brackets, at least the code that belongs to that particular function. Now that is really it. Of course you can delete all of these comments, but you have to retain those 2 functions. See, this is the smallest Arduino program you can write, and every program ever written will have these 2 functions in it. That's it. Now let's fill these functions with some important information so that the EZA board will actually start doing things. This is the microcontroller. This is the mini computer that runs your Arduino code and controls the entire EZA board. And the microcontroller interacts with the outside world using its pins. And on this particular board, pin 30 of the microcontroller is connected to the backlight, and I would like to turn the backlight on. Okay, let's start here at the beginning. We declare the pin in the list of items. So please type along. Byte backlight is 30 semicolon. Okay, let me explain that. Byte here is the data type. I'll come back to that later. Just notice for now that it's lowercase. Then we have the pin name. Now, this doesn't actually need to be called backlight. It can be called whatever you want, because it's just a nickname of referring to pin 30. Even though you can call it whatever you want, you cannot start with a number, and you cannot have a space in a pin name. Also notice that the first word starts with a lowercase letter, and any subsequent words will start with an uppercase letter. That's a convention you'll see throughout Arduino. At the end of the statements, you see a semicolon. And in fact, every statement in Arduino needs to be terminated with a semicolon. It's like the period. There's one exception, however, and that is an organizational structure. For example, our functions void setup and void loop, they are organizational structures. They organize other statements. And everything inside, every statement inside will need its own semicolon. And by the way, when I say inside, I mean inside the curly brackets, because all the code that belongs to a function always goes inside the curly brackets. We've told the program, yes, we have this backlight pin. We're going to be using it to control the backlight. But every user accessible pin can either be an input or an output. It can listen or it can speak. And we need this backlight pin to become an output, because that will enable it to send out a signal to the backlight to turn it on. Okay, how do we turn this into an output? Well, you need a new command. And since a command is an action, you cannot put it here, but it has to go inside one of the functions. All actions have to go inside functions. And the most logical place to put it is inside the setup, because it only runs once on startup. So this is the ideal place to configure the pin as an output. Let me introduce you to our first command. It's called pin mode. The mode of a pin. Only one word, lowercase p, uppercase m. It needs to be followed by a set of parentheses and a semicolon. And in order to tell the pin mode what to do, we do need two things within the parentheses. First, you specify your pin name, backlight. Then there's a comma, and then you specify what mode do you want the pin to be. And in caps, we'll say output. All right, the backlight is an output. Now, all outputs are like light switches. They can be on or off. And by default, an output is off. We don't want the backlight to remain off. We want to turn that on. How do we do that? Well, first let me say, in Arduino you don't actually talk about on and off. You talk about high or low. Okay, high meaning on and low meaning off. How do we turn the backlight high? Well, several ways of doing that, but we'll use the most important Arduino command. It is called digital write. One word, lowercase d, uppercase W. And just like the pin mode command, we have a set of parentheses and a semicolon. And just like the pin mode command, we need 2 bits of information inside. First, we specify what pin do we want to write to. That's the backlight. Then a comma, and then we specify what state do we want it to be. In caps, high. Excellent. And that is it. I just want to say one more thing. I'm in the habit of leaving a space here. I think it looks good. Not technically required. I also often leave a tab here inside a function. That's up to you. Arduino is easy. It basically ignores white space, so you'll develop your own habits over time. We're ready to upload, but you need to configure a few settings, and you'll find those settings on the very first page of my free book, available at easyAboard.com. And once you've done that, you can go to Sketch, upload using Programmer, and let's see, the backlight just turned on. Excellent. It's starting to get interesting. It's time for another exercise. I want you to delete everything we've done so far, and I want you to turn on this green light on pin 8. I'm going to show you some tips. Just give it a try. If you get stuck, press the check mark here. And just give it a try. Pause the video, then we'll discuss it together. Alright, I hope you were able to do this, because this is really the basis of all the exciting things we'll be doing later on. You should have started by declaring your pin. So byte green light is 8. Now of course you could have chosen another name, that's totally up to you. Then inside the setup we go inside the curly brackets, and here we need the pin mode command with parentheses and a semicolon. Inside we need 2 things, green light, comma, in caps, output. Now the green light pin is an output, so it's capable of sending out a signal to the green light. Alright, we digital write with parentheses and semicolon, green light, comma, in caps, high. And that's it, right? Well, let's upload and see. And oh, there's an error. What could that be? Well, remember that every Arduino program has 3 sections: the list of items, the setup function, and the loop function. And even though we're leaving the loop empty, it still has to be included. Void loop, parentheses, curly brackets, and look at that, the green light just turned on. You say, okay Matthew, a green light, that's okay, but can we make it a little more exciting? Sure, let's make this light blink. Now I could continue writing code right here inside the setup. However, I would run into a problem, because the setup only runs once. So, with the blink code, I would only get 1 blink. And that is just a terrible disappointment. I'll just cut this statement and put it inside the curly brackets of the loop. And since the loop repeats over and over, I'll get an infinite number of blinks as long as I'm patient enough. We'll start by turning the light on. Then we want to wait a while before we turn it back off. Now there is no command called wait, but there is a command called delay. That's lowercase delay followed by some parentheses and a semicolon. And within the parentheses we do need a duration, and I'll say 500. And that 500 is measured in milliseconds. Tiny little thousandths of a second. So we wait half a second. And then we want to turn the light back off. Now that requires another digital write statement with a small tweak. Parentheses, semicolon. Inside we say green light, comma, in caps, low. Low, not high. Excellent. At this point, we've reached the end of the loop. And that means, since we're inside the loop, it's going to loop around and start over at the beginning. So the light turns on, off, around, on, off, around, on, off, repeat, forever and ever. Okay, let's give that a try. Sketch, upload using programmer, and as you can see, that light is not turning off. Well, no problem. We'll figure out what's going on in just a minute because I've got an oscilloscope. This is like a heart rate monitor for electronics, which is fantastic because since you cannot see electricity, you need an oscilloscope to make electricity visible for you. So the signal is sitting at 0 volts since I've got nothing connected, but as soon as I connect the probe to the light, I get 5 volts. That's what you would expect. The light is getting 5 volts, therefore it is on. Did you see that? There's some kind of glitch going on. Let me zoom in on that because that might be interesting. Actually it's not a glitch. This light is in fact off. Can you see that? It's off for a very brief duration, but regardless it is off. Now, maybe you can go back to the code and see if you can figure out why this light is not staying off. You can pause the video and maybe you can even find a solution. At the end of the code, the light turns off. Then we go around and turn it back on. You say, I still don't see the problem. Well, you don't realize how fast this microcontroller is. At the end, the light turns off, whoop, and back on. Off, whoop, on. And this happens so quickly, you cannot possibly see it. But as we saw on the oscilloscope, the light is in fact off, only for a few millionths of a second. The solution is to include another delay here after we turn the light off. And that will ensure that the light actually stays off for half a second. Now it will stay on for half a second and stay off for half a second, exactly as this. Congratulations, we've done another important lesson. This is a rocket igniter. It consists of a very thin wire of nichrome, and if you send a lot of power through that wire, it will start glowing red hot. If the igniter is in contact with a rocket motor at that time, the rocket motor in turn will ignite and send your rocket up into the air. Now we're going to set this igniter off, and the EZA board by itself doesn't quite have enough power to make this glow red hot, but I do have an accessory board. This can do a number of functions, and that includes 4 high power outputs, and those can, among other things, ignite this rocket igniter. Let's write some code, and I'm going to start by declaring this pin that controls the igniter. So byte igniter is 10.2 semicolon. And as always, void setup, void loop, parentheses, curly brackets. Yeah, you'll have to type it every time, otherwise your code won't work. We do need to make this igniter an output, because that makes it capable of sending out a signal to the accessory board, which will in turn amplify it and send it to the igniter. Okay, turning an igniter or any pin into an output is done using the pin mode command, parentheses, semicolon, and inside I'll say igniter, comma, in caps, output. Now you know that outputs by default are off. And that's not what we want to turn the igniter on. Digital, write, parentheses, semicolon, igniter, high. Excellent. Sketch, upload using programmer. And yes. Whoa. So, you know, only a small little flame, but all you need to set this rocket motor off. Now this is good. It's good that it's capable. However, we can do better, because when you're turning this board on, the rocket motor starts right away while you're standing next to it, which could be dangerous. So let's program a delay in here so that you turn on the EZA board, you run away, then the rocket launches into the air. Okay, let's write some code. Actually, you just learned how to do that. Let me go right before the digital write statement and include our new command, delay, followed by some parentheses and a semicolon. And inside the parentheses, I specify a duration. I'll say 3000, meaning 3 seconds. Okay, 1, 2, 3, ignite. Yes. Woo! Rocket went up into the air. Now this is a big improvement. There's another improvement we can make, because these clips will usually fall to the ground once the rocket takes off. And that could be a problem, because if these touch, you get a short circuit. That is a massive amount of electricity going from plus to minus with hardly any resistance, and you can burn things out. So let's just program in some code to make sure that doesn't happen. This line here turns the igniter on. We do need to give the igniter a bit of time to heat up, so we'll put in another delay. I'll say 2000, and then after the rocket has been ignited, we digital write the igniter low, close parentheses, semicolon. Alright, sketch, upload using programmer. 1, 2, 3, ignite, and cut off. And now these clips are safe to touch, no problem, because we've turned the power off. Alright, we're finally ready for the exciting part. I've got the igniter hooked up to the rocket motor, and I've got a scientifically approved ignition vessel. Well, I consider it scientifically approved. It doesn't say you should not do this indoors, so I bet that means you can do whatever you want. Now, I've never done this before. If I plug this in, I've got 3 seconds. Okay, there we go. 1, 2. Whoa! Alright, see, smells like fireworks. See, that's how much fun you can have using the EZA board and the Arduino. Alright, let's learn some more exciting things.